Okay, so within ellipses, the picture here we've got, you'll notice, as I said, we have a center point. We're just going to kind of go down the vocabulary here. So if I'm filling in the vocab, the center, just like the circle, we use the letters H and K for the center. You'll notice we have basically two forms for our standard form. We have x minus h squared over a squared plus y minus k squared over b squared equals 1. And then the flip of that is where a squared is under the y and b squared is under the x, but it's still, again, equal to 1. We're going to talk about what these letters mean. The x and the y, they represent the points on the ellipse, just like in a circle. The vertices, so when we're looking at the picture, the vertices, or the vertex, so to speak, will lie on the major axis. So basically, this is the distance of A, so the letter A, the distance of A away from the center. Yeah, they're right back here, next to the drawers there. On the table below, beside, on the far left. Okay, so if I were looking at this picture here, let's say this particular ellipse right here, the A value, again, tells us the endpoints of our vertices here. So if I knew in this particular one that A is, let's say, 3, and this is at 0, 0, then we know that the vertices would be at 3, 0, and negative 3, 0. And we're going to do an example here in just a minute so you can kind of better see that. The co-vertices, they are the endpoints of the minor axis. That's going to be the distance of the letter B away from the center. Again, notice when we're looking at standard form, when we're talking about the difference between A and B, the bigger value will always be the A value. And that's kind of how we know which one's A or B when you're looking at the numbers. So if A is under X, it will be horizontal. If A is under Y, it will be vertical. Now, the length of the major axis is the longest axis. And it's represented by the expression 2 times A. So if we know that A is 5, then the length of the major axis is going to be 10. The length of the minor axis is that's the shorter or shortest axis. It's represented by the expression 2B, or 2 times B. Now, when we're labeling these things, I'm going to go back up here to my picture at the top. When we're labeling these, this distance, as we said, from the center to the vertex, that's representing the letter A. The distance from the co-vertice to the center, that's letter B. And then the distance from the center to the focus, or the foci, that is our C value. So when we are finding that distance to the focus or to the foci, there's a Pythagorean relationship, and that relationship is A squared minus B squared equals C squared. So the length of A squared minus the length of B squared is equal to the length of c squared. The foci, these are the points that are on the major axis. And they represent the distance c from the center. Now we have one last vocab term that we talk about, and that's this concept of eccentricity. So eccentricity is basically the ratio of the c value to the a value. And the eccentricity will always be less than 1. Now you say, why is that important, or what's the eccentricity really have to do with the ellipse? Well, basically, the bigger the eccentricity, the flatter the ellipse is going to be. So the smaller the eccentricity, kind of the more rounded it's going to be, or the closer that it would be to being like a circle. So those are our basic definitions and vocabulary that goes with the ellipse. What I want to do is we're going to go through 2 examples, and they're on the next page. We're going to do one that's at 0, 0, and we're going to do one that's not at 0, 0. So as you look at this or these problems, the first thing you're going to find is the center. And again, it's got to be in standard form, just like a circle. So hopefully you recognize from our experience with circles that this center would be at 0, 0, because there's nothing with my x, there's nothing with my y. So h and k are 0, 0. We're next going to identify the vertices. So the vertices are represented by our a squared value. So notice here which is the bigger of the two. 25 would be the bigger of the two, so we'd say a squared equals 25. And if we solve for a, we would get that a is 5. Now what that tells us, and I'm going to make the graph as we go along here just so that you understand what we're finding. Because our a value is 5, and because our a value is under the y, that tells us that we have a vertical ellipse, because the a value is underneath the y. Now because it's vertical, that means from 0, 0, we're going to count up 5, and we're going to count down 5. So there's my 2 vertices of my major axis, and those 2 points are 0, 5, and 0, negative 5. Once we find the vertices, then we're going to find the co-vertices, which are basically the endpoints of the minor axis. And that's telling us, or being told to us, by our b value. So we know in this one that b squared is equal to 9. So b would have to be 3. Well, our minor axis is going to go horizontally because it's underneath the x. So we're going to count right 3 and left 3. And those 2 points are going to be 3, 0, negative 3, 0. Once we've found the endpoints of our vertices, both our regular vertices and our co-vertices, we're then going to find the foci. Again, these are the 2 important points that we recognize within the ellipse. So the foci, we're going to use our formula a squared minus b squared equals c squared. Well, in this problem, a squared is 25, b squared is 9. This one works out really nicely. 25 minus 9 is 16. So our c value is 4. Again, our foci lie on the major axis, which is the longest axis. So I'm going to count up 4, 1, 2, 3, 4. And I'm going to count down 4, 1, 2, 3, 4. So my foci, in this case, lie at the points 0, 4, and 0, negative 4. And really, after I have all these plotted, I can go ahead and sketch in my ellipse. Again, you want your lines to be somewhat curved. Looks like an oval shape. Question. The other thing that we're going to find here is we're going to find the length of the major axis. Which really, you can count it here, or you can, again, it's 2 times a, so it's the length of the major axis is going to be 10. The length of the minor axis, we know that b is 3, so the length of the minor axis would have to be 6. That's 2 times b. And then the last thing would be our eccentricity. And remember, to find our eccentricity, it's the c value over the a value, which in this case, c over a would be 4 over 5. Again, that number, the higher that number is, or the closer it is to 1, the more flat that it's going to be. And then the smaller, the more rounded that it's going to be.